If you purchase the CanCam's optional infrared probe, this is how you can use it. So first we're going to change to the correct tool. In this machine's case, it's tool 9M06. Run. The machine's going to go pick up our probe in the holder. Once your probe is being received, you're going to get a notification saying spindle disabled, touch probe is in use. Hit OK, make sure that we know that. We'll then go back to our F3 jog page. In our F3, we're going to set up our probing operations. To do this, we're going to hit our probe menu here. With this probe, we have access to all of the probing features in the Masso's capability. We're going to start with using a circular bore, find the center of a circle. Then we'll do our corner probe and a single Z probe as well. First thing is we have to line up our probe with the object. We're going to start with our circular probe. Jog it into position. Do a rough, following by using your MPG to lower your Z-axis into the hole, making sure our X and Y alignment is correct to prevent damage to our probe. Once the probe is in position, you're going to press the icon on the probing screen.
One side.
And it is going to continue to do the probing cycle. Once you've completed the circular bore operation, it's going to return to XY0 position and set it to the center of that bore. To get our Z offset, we're just going to raise our spindle up using our MPG out of the hole, locate it either on top of our material or on top of the machine bed, depending on how you set up your program. In this case, we're going to do it material surface. To activate the Z probe, we're going to press the single red dot in the center of the square on your probing screen, and your Z axis will slowly move down until it probes the surface of your material. Once it's concluded that probing operation, it's going to automatically set that Z position as 0. Next operation we're going to do is corner probing, so we're going to find this corner here, bottom left hand, and we're going to put it on the front face. You always want to start where the arrow is pointing, and then it will move to the next position. With this piece, we're going to be moving ½ an inch on our X-axis in order to control. To do that, we're going to hit the side here. It will move over here. So we suggest putting it at least ¼ inch over your material. If it does more than that, it'll cause an error in your probing cycle. Once it's in position, activate it by simply pressing the button. Once it's done the sequence, it's going to stop. We can exit our probing, F2 program MDI, go to work origin, our Z will raise, and it will move over XY0 directly over the corner of your workpiece. To do a calibration on our probe, we're going to need a few things. First is our magnetic base, a 1/1000th indicator, as well as a 10/1000th indicator for further refinement. Last thing is we're going to need an Allen key set, preferably in metric. To do a calibration on it, we're going to set up our indicator so it just touches off on our probe, the base. You can do refinements with this screw, and we want to just touch the tip off and get it close to 0 here. Once it's done, we're going to grab up by the tool holder, not the base itself, but the tool holder, and rotate this within. Ideally, we want to see 0 tolerance, but once it gets down to this size on your tenths or 1,000ths indicator, we can switch to our tenths indicator. Now that we have our tenths indicator installed again, we can see it zeroed out. We're going to do the same test, rotate up by the tool holder, and we want to see again 0 tenths indication, and we are getting looks like 4 tenths in this case. So we're going to need to adjust this better. I'm going to reposition my 0 so I have a better reference. So to confirm, we are 4 tenths out of round. So to make this adjustment, we're going to take our Allen key set. We have some screws in the top, 2 on either side 180 degrees apart, and 1 on either side 25 degrees apart. The top 2 hold the probe in position, and the bottom ones, with loosening and tightening the sides equivalently, will adjust where the tip of our probe is. Typically, it's best to operate the probe in one direction, so if you're rotating it clockwise, continue to rotate it clockwise, as it can cause some deflection in your indicator. It's easiest to set your indicator up at 0 with a reference point at the top. I like to use the 2 indications, and I'm going to do a half rotation so we can again see 2 indications up. We can see that from that side to the other side, we are 5 tenths towards the front of the machine. So we want to tighten this screw and loosen the screw in behind. So we'll first start by rotating it again 180 degrees, getting your Allen key, loosening this side, just a small amount, rotating it 180 degrees, tightening, rotating it 180 degrees again, and tightening this back into place to make sure we're locked in position. We're then going to take a 0 reading again. Indicated there. 0 again, and rotate 180 degrees. We can now see we're only 2 10,000ths of an inch out. Ideally, we want 0. Typical tolerance is 1/10 out. So we're going to have to adjust this again. We want to loosen the other side. Rotate 180 degrees. Loosen. Rotate 180 degrees. Again, trying to stay the same direction. And we will tighten. That was too much. And then we'll tighten the other side up again. Re-zero our indicator. It's important to re-zero your indicator after every time because our position might change due to those adjustments. Rotate 180 degrees. And now we've gone too far the other way. This might take some time. So now that we've adjusted it in all 4 axes, we can rotate the piece and we can see on our dial we have 0 motion. And that is what we're looking for. To calibrate the tools in your aggregate head, you're going to first need to switch over to your aggregate. To do so, we want to make sure our aggregate is oriented correctly. So if we look at our spindle, we want to see the tang here. We can see it's currently not there. So to make sure that it's centered, what we're going to do is go into our MDI screen. We're going to type in G53, G00, B, no, that's B0, run. It's going to rotate our C axis so the tang is in the front. That's when we know it's in the correct position. Next, we're going to change the tool over to our aggregate, T10, M06, just a standard tool change command, run. So the next step that we have to do is to get the aggregate out of our spindle, position it in the 0 degrees orientation, and install our tool. So dust it up, it's the easiest way to get everything out. Grab hold of your tool. The aggregate is quite heavy, so do be aware. Press the green button on the side of your spindle. It's going to drop out. Next, we're going to need to get our Allen keys and loosen these 3 bolts. All right, so we're just going to crack these loose just a little bit. You don't have to snug them up too much. It has a maximum torque of 6 Newton meters. Now we're going to straighten it out. So we want to line our 0 up on our gauge with the 0 at the front. There we go. We're going to tighten everything back into place just to make sure it doesn't move. And we're going to grab a tool. So with the aggregate, we're going to clip our collet in, just like a standard collet, press it in, make sure it's flush to the front, install our tool, and spin it onto the nut. This gray back collar is fixed to our taper, so we can hold it to prevent it from rotating. Once you get it in place, we can use our wrench and our collar wrench to hold everything in position. Snug her up. Once that's done, the aggregate doesn't have a locking mechanism on it, so you move the jam nut up and you lock the jam nut to your collet. This time we're going to install it back into the spindle. Make sure your dog is lined up with the keyway. Give it a wiggle, make sure it's set in place. If you feel any play in the dog, you have not installed your aggregate in correctly. Once you've reached this part, we're going to have to auto tool 0 our machine on our F4 tools and offsets page. Find tool number 10, aggregate, double tap, auto tool 0, just like any of your regular tools. Once it's done, save. At this time, we're going to have to remove our aggregate, adjust our 3 bolts to the desired angle that we wish, in this instance, I'm going to set it to 90 degrees. Again, line the 0 up with the 90. And then tighten it up. At this time, if you have a torque wrench, tighten it up to the recommended 6 Newton meters. And install it back into your tool holder. Again, confirming it's locked in place. Once you've calibrated your aggregate in the straight down position, record your value in your Z offset here, either an imperial or metric, doesn't really matter. picture is the best way. From here, we're going to have to go over to the software to input these values into the Fusion in order to get the correct angles. Okay, so we're going to have a look at how to cut this piece on the side and how to operate and set up the aggregate head on your machine. So what we're just going to be doing is just a nice little channel with radiused corners on each corner, and that'll be done in one toolpath. All right, so the first thing that we need to know is we need to gather a couple of bits of information from the CNC machine itself. So I'm just going to open this notepad up. So first thing is we have to set our aggregate to 0 degrees. It's pointing straight down from the spindle. We're going to remove the tool and the collet nut, and we're going to do an auto tool calibration on tool number 10. This is going to get us our base value. The purpose of this is to get a proper reference point from a known location on the aggregate head to the center of rotation in reference on the machine. So once you do that, you're going to get sort of a value in your Z offset for tool number 10. It's going to read something like this, minus 500 millimeters as an example. If you're running an imperial, then it's going to be an imperial number, whatever. Next, we're going to have to install a tool into the aggregate. So collet nuts back on, collet in, and a tool in. Recalibrate your tool for number 10. And as another example, we're going to get minus 450. It's always going to be a smaller value than your base because the tool's in there and it has to travel a smaller distance. We're going to take the two values here and we're going to subtract them together to get a length of 50 millimeters in this example. All right, I've already created a toolpath, so we're just going to open this up quickly. And we're going to select our tool. So the first very important thing is we have to input a tool length for this. If we have to rewrite the program because the tool broke and you've re-put in a new tool, you will have to come back, get that measurement again, and come back and edit the tool and rewrite the program. To cutter. And this one here, overall length, this is the one that we have to change. So we want to make sure that this matches whatever we get from subtracting our base value and our tool length value together. All right, once that's done, we're going to hit accept and select. All right, from here, again, this is just Fusion. You're going to select your chain and the orientation that you're going to be cutting from. In this case, I've selected the Z side there. So it's done, we're going to hit OK. And let's do a simulation. What's going on? Okay, simulation. So again, it's going to come in and cut the piece. As we can see, as it makes the corner, we're doing a complex curve with all of our axes to work in unison to create that complex corner. Perfect. That's going to work for us. Once we're done, we're going to post it out. There's one important thing that we have to do in our posting here. So translate aggregate to spindle. We want to make sure that's checked. And if we're in metric, we're going to make sure that this says 81 millimeters. And if we're in imperial, we're going to have to convert 81 millimeters to the imperial value there. Okay. Once we're done, just hit post. Yes. Calibrate this name. So let's look at line 25 here. We can see it goes to line 24. It goes to X272. So this should allow for the offset value from the distance from center of your spindle to the tip of the tool at this 90-degree aggregate. If you set up your aggregate at a different angle, as long as you have it matching here and on your machine, it will calculate the correct distance to the point where you're cutting. It's going to be done. It'll do that automatically based off of the aggregate length that we installed in the post and the tool length. So it adds those together and allows it to be triangulated. To double check, we can go into our post processor. Let's deselect this. We're going to post it out as 102. Post. Yes.
going to pop up, and we're going to see line 24, X141. So X141 and 272, that should basically be our 81 plus 50 millimeters distance apart, and we should be able to do the math to get that figured out to show us that's what it's done. Anyway, that is how your aggregate is going to work in your post and how you have to set it up on the machine. Again, very important to remember that if you break your tool, you're going to have to go back into the program and rewrite the program with the correct tool length offset. Otherwise, it won't be able to translate that properly to your material.